Yes, good evening student. Am I audible? Am I audible to you? Am I audible? Can you? Okay, good. Okay, so today we will discuss about assignment third. Okay, which is belongs to third week lectures. And before that, we will discuss about the brief of the all lectures. Okay, then we will discuss assignment. If you have any query, any question, then also you can ask. Okay, meanwhile discussion or before the class, after class, whenever you have any question, you just raise your hand and then you can ask the question. Okay, so we just wait for 2 to 3 minutes, then we will start. Okay, we will start at 7:05 because only 8 students join, 9 join now. Okay, if my voice is not clear or screen is not visible to you, please inform me. Okay, and while discussion, please keep your mic muted. Please keep your mic muted. Yes. Okay, I am going to start now. So this lecture, this week we discussed about the chemical equilibrium. Okay, in week third, the detail about the chemical equilibrium has been discussed. First of all, it should be understood that what is the equilibrium. Okay, so simply if you we all know about the balance. Okay, let me draw. Suppose okay, and suppose this is the middle part of balance. Okay, and you have two band of it. Okay, suppose this is the balance and these are the two pan of balance. If you are taking 5 kg here and same 5 kg here, so what is the meaning of this thing? That the needle will be remain at the mid, and you can say that your balance is in equilibrium because both side are equal. Okay, so and suppose you are going to reduce your weight. Suppose in right hand side I am going to reduce 5 to 4.5 suppose. Okay, so I will write here 4.5 kg. Okay, so what I am doing here, I am disturbing the equilibrium. Okay, I am disturbing the initial equilibrium. Okay, so now what will happen, it will change. Okay, the middle point will be changed and now it will be okay, and the needle will be like that. Okay, because one side has sorry, it is just a reverse. Okay, so I just need, so this will be 4.5 kg. And it will be 5 kg. Okay, so what happened that I just disturbed the equilibrium. Okay, but now another equilibrium has been established where the pain is declined toward right hand side due to higher weight. Okay, so again equilibrium is established. So same thing happen in chemical reaction also. Okay, so suppose I am writing A plus B. Okay, and it is producing C and D, simplest. Okay, so initially time is equal to 0 means please mute yourself, I am getting some noise. Okay, so it will be very, please mute yourself, Abhishek and Raghav. Okay, so team time is equal to 0, suppose A has x concentration and B has y concentration. Okay, so a time is equal to 0 and C and D will be 0 concentration. Okay, but suppose a time after 10 minutes. Okay, after 10 minutes reaction will be happen, or we can say x minus suppose x minus small a and y minus small b. Okay, so means some reactant react together and make some product. Okay, so this product can, we can say, suppose it is suppose M and N concentration. Okay, for understanding only, like that reaction is happening. Okay, so this is called as a forward reaction. So first of all we will discuss about only forward reaction. Okay, so this reaction will be called as forward reaction. Okay, so in forward reaction C and D as a product will be formed. Okay, but after some time C and D will also will react and make A and B. Okay, so it will called backward reaction. Okay, so there are two types of reaction, forward reaction and backward reaction. Initially the rate of forward reaction very high and backward reaction very low, but after some time when equilibrium will be established, forward reaction rate what we can say simply that, yes, we can say that rate of forward reaction will be equal to rate of backward reaction. Okay, so it will call equilibrium. Okay, now the concentration of A and B and concentration of C and D will remain same at the equilibrium. Okay, because reaction happening in this direction and reaction happening in this direction is equal. Okay, so all over will be means there will be no change. Okay, so initially it is equilibrium, but this equilibrium can be disturbed. Okay, this equilibrium is we discuss about the balance. Okay, if we are changing the weight, then the plane of balance will change their position. Similarly, if any chemical equilibrium, if you are changing temperature, pressure, concentration, okay, so these are the three parameters: temperature, pressure, concentration, or volume. We also can say sometime volume. Okay, if you are changing this parameter, then also equilibrium can be changed. Okay, so this parameter what means, how by changing this parameter your equilibrium will be disturbed and in which direction equilibrium will be moved. Okay, so this will be discussed in according to Le Chatelier principle. Okay, So we will also discuss about this principle in detail. Okay, how it can be change your equilibrium. Okay, so step by step we will discuss. Okay, so why we are, first of all, this question will be rise in your mind, why we are discussing about the chemical equilibrium. So chemical equilibrium is very important in analytical chemistry. Okay, simply you all know about the titration. Okay, in titration also equilibrium will be established at the end point. Okay, so that you can understand that means you can identify end point and you can analyze that reaction is completed. Okay, so in titration, so means general way to measure end point. Okay, suppose so in titration also we cannot take only one reading and we cannot finalize our data. Okay, to finalize our data we need to take at least 3 readings. Okay, suppose initially you are taking your reading is 25.5. Okay, so you know that my reading is near about 25.5, but it is not exactly 25.5. So next time what will you do, you will add your solution up to 24.5, then you add drop by drop. Okay, and then you will measure, suppose your reading is like okay, you are adding drop by drop and suppose your reading is 25.3. Okay, so you got that this reading, this is the right reading, but to confirm that it is the accurately right reading, you need to do third titration. Okay, and in third titration, if it is also coming like 25.3 only, then you can say yes, my reading is accurate and this is the correct reading of titration. Okay, so and one more precaution you need to carry over while titration, that the color change should be remain for 30 seconds. Okay, if it is, please mute yourself, Kumar. Yeah, okay, so if color is disappearing before 30 seconds, then you can say that reaction is not complete, some solution is still there. Okay, and it is taking time to react, so you need to wait till 30 seconds. Okay, so the equilibrium in lectures are explained how the stalactites and stalagmites are generated due to formation of calcium due to deposition of calcium carbonate. Okay, so this is the simple reaction, calcium carbonate. Okay, in the presence of water and in presence of CO2. Okay, so this is also a reversible reaction where calcium will be dissolved in water. Okay, and it will form Ca+2 ion plus it is HCO3 minus. Okay, so when it is dissolved, okay, so it will make colorless solution. Okay, but when CO2 will again remove from the solution, then it will again make precipitation of calcium carbonate. Okay, due to that this type of structure will be formed after some time, and it is also, you can say, it is a form of equilibrium. Okay, so this is the simplest example of equilibrium, and I have already explained this thing. Then in second lecture, sir explained about the explained about the electrolytes. Okay, electrolytes. Okay, so electrolytes means what? This will provide ions. Okay, and due to ions, the solution will be able to conduct electricity. Okay, they will provide ions in what? In solution like water. Okay, if any electrolyte will be dissolved in water, simple means it is universal solvent. Water is universal solvent. So when any electrolyte will be dissolved in water, it will provide ions, and this ion will able to conduct electricity. Okay, so that's why it is known as electrolyte. So simplest example of electrolyte is NaCl. Okay, why NaCl is taking? Because we all know about the NaCl. When NaCl is dissolved in water, okay, you will get colorless solution, but Na plus and Cl minus ion will be there. Okay, and it is also surrounded by some water molecule. It is not like that. Okay, some water molecule will be covered these ions like that. Okay, so this is the dissolution of NaCl, and it is also electrolyte. Okay, so on the basis of their you can say, on the basis of their dissociation in water or any solvent, we can say that it is strong electrolyte or weak electrolyte. Okay, so NaCl is strong electrolyte. Okay, and you can also consider that how NaCl is formed. So NaCl is formed from NaOH plus HCl. Okay, so NaOH is strong base, where HCl is strong acid. Okay, so when strong base and strong acid will react, they will form strong electrolyte. Okay, similarly, suppose you are talking about the CH3 COONA, it is also electrolyte. So the positive part is Na and negative part is CH3ON. When it will dissolve, it will give you two ions, which is CH3 CO minus acetate ion plus Na plus ion. Okay, so how this electrolyte is formed? So it will be formed like, okay, so you can say it can be formed like acetic acid, CH3COOH plus you can say NaOH. Okay, so when this acid and base will react, it will form CH3CON electrolyte. Okay, so NaOH is strong base, we know, but CH3COH is acetic acid, which is weak acid. Okay, it is weak acid. That's why it will provide you electrolyte, which is weak electrolyte. Okay, it will not dissociate fully in water. Okay, so according to their composition, we can say it will be strong or weak electrolyte. Okay, so obviously NaCl is strong electrolyte, where sodium acetate is weak electrolyte, and it will be only partially dissociate in water. But there is one more concept is, you cannot consider any electrolyte as a weak or strong. Okay, you need to explain solvent also. Okay, in which solvent it will behave as strong or it will behave weak. Okay, so we can take one example for that. Suppose suppose we are taking HCl. Okay, so HCl is strong acid, we know, but in water HCl will be dissociated fully, and it will give you H plus Cl minus ion. Okay, but okay, according to that you can say HCl is strong acid. Okay, but you need to say that HCl is strong acid in water. Why it is so? Because suppose you are taking HCl in acetic acid, CH3COH. Okay, so what will happen? It will give you chloride ion plus CH3COOH2 plus. Okay, but here, because it is a weak acid, okay, so in simply we can say what is happening here, that HCl giving proton to acetic acid. Okay, but acetic acid is not neutral, it is also weak acid, so it will not it is not very prone to take proton. Okay, so water is more, you can say more a more strong compared to acetic acid to take proton from HCl. That's why HCl will be strong acid in water, but it will behave as a weak acid in acetic acid. Okay, so before declaring any acid, base or any electrolyte as a strong or weak, you need to mention that in which solvent you are talking about. Okay, then only you can say. Okay, so same example you can take for electrolyte also. Okay, at the place of HCl you can write salt. Okay, suppose I am writing NaOH here, sorry NaCl here. Okay, here also I am writing NaCl. Okay, so what is happening here? Na ion will be provided to acetate ion, but as acetate is weak acid, so it will weak compared to water. Okay, so like that what will happen here? Okay, so it will form, just a minute. Here it will form HCl plus NaOH. Okay, so NaCl is behaving as a strong electrolyte here, but here as Na ion should be provided to acetic ion. Okay, so so the strength of the NaCl electrolyte will be decreased. Okay, clear this point? Okay, so on the basis of this thing we can classify strong and weak electrolyte. Okay, like all inorganic acid like HCl, HNO3. Okay, these are strong electrolyte. Same alkali and alkaline hydroxide like NaOH. Okay, then KOH, then we can say CaOH2, calcium hydroxide, MgOH2. These all are strong electrolyte. Okay, most salt. Okay, many salt like NaCl, barium sulfate. Okay, these salts are known as strong electrolyte. Then weak electrolyte. Okay, some acids which are like H2CO3. Okay, then H3PO3. Okay, H3PO4. Okay, these acids are weak acid. Okay, so if this question will be rise in your mind that HCl is a strong acid. Okay, it is also contain H and Cl. Okay, then why these acids are weak acid? Okay, so if you want to understand about that, then you need to understand about their structure, and then you will only able to understand that why it is weak acid. Okay, so for your understanding I will explain about the H3PO3. Okay, then what is the structure of H3PO3 is, okay, because boron is what, 5. Okay, so its electronic structure is 1s2, 2s2, and how much, 2p1. Okay, so it can make only 3 bonds. Okay, so when it will make 3 bonds, the how many electrons will be there? So 3 plus 3. Okay, total 6 electron will be there in outermost shell. In this structure which I mentioned here. Okay, so 3 electrons are shared by boron, and 1 and 1, and 3 electrons shared by oxygen. Total 6 electrons are there in outermost shell of boron, and it is taught in 12th grade that to stable any structure there should be 8 electrons. Okay, there should be 8 electrons in outermost shell. Okay, so how it can satisfy 8 electron. So suppose it is dissolved in water, HO, okay, suppose H2O. So I am writing in this way. So what will happen? This hydroxide will be attached by boron, because boron is electron deficient. Okay, boron is electron deficient, so hydroxide will be attached, attracted by boron. Okay, so finally what will happen? Finally, what will happen, that you can say OH will provide its 2 electron and hydrogen will be kick out. Okay, so due to this hydrogen, your solution will become acid. Okay, so this reaction is not very easy as HCl, H plus Cl. Okay, it will instantly give you H plus and Cl, so it is a strong acid, but it will take time, and it is it will considered as a weak acid. Similarly, you can also at home you can find out why H3PO3 and H2CO3 is, are weak acid. Okay, it is very interesting. So according to their structure, you can say it will be weak or strong. Okay. Then other example of weak electrolyte are organic acid. Okay, which we have already discussed about the acidic acid. Then oxalic acid. Okay, this is also 2 plus 2, so how much will be there? 0. Okay, it is completed. Okay, oxalic acid, acidic acid, these are the weak acid. Then ammonia. Okay, ammonia is weak base. Why it is so? So means sodium hydroxide. Okay, again we will compare with a strong base like sodium hydroxide. When it will dissociate, it will give Na plus OH minus ion. Okay, but how ammonia will be dissociate? No, ammonia will not dissociate. Then why it is considered as base? Because if you again, okay, to understand its basicity, you need to understand its structure. Okay, so this is the structure of ammonia. Okay, so ammonia is again N7. Okay, so 1s2, 2s2 and 2p. How much? It will be 3. Okay, so 3 electrons are there in p cell, so it will make 3 bonds. Okay, it will make 3 bonds, but this 2s electron will remain as a lone pair. Okay, so you can see here, this is the lone pair. Okay, so lone pair is there, so this lone pair will be provided to other positive ion. Okay, like suppose it is H plus, so H plus will be attracted by this lone pair, and it will make NH4, ammonium ion. Okay, so because it is giving electron or it is accepting the proton, that's why we will consider ammonia as a basic in nature. Okay, so NaOH is also base, ammonia is also base, but ammonia is weak base, and also the mechanism of their basicity is different. Okay, in NaOH, okay, this meeting will be ended in after 10 minutes, so you need to join same link again. Okay, so NaOH and ammonia both are working similarly, but means both are showing basic in nature, but their mechanism are different. Okay, that's why I explain this thing here. Then halides, cyanides. Halides means X minus, or okay, X can be BCl, Br, I, and one more fluoride. Okay, it can be either bromide, fluoride, iodide. Okay, so halides. Then cyanide. Cyanide is what? Cn minus. Then thiocyanide. Okay, SCN minus. Of what? Which elements? Mercury, zinc, and cadmium. Okay, so these are also these salts are also considered as weak electrolyte. Okay, so I think it is clear. If you have any doubt, you can write me in chat box also. Okay, one more example. Suppose sulfuric acid H2SO4. We all know, okay, king of acid, it is known as king of acid. When it will be dissociate, it will give you H plus plus HSO4 minus. Okay, so it is a very strong acid, but when it will give you one proton, then it will give you HSO4 minus. This ion also contain one proton, and it can also dissociate as H plus plus SO4 minus 2. Okay, but this is not as much easy as H2SO4. Okay, so it will not consider as strong electrolyte as H2SO4. Okay, because it is already negative ion, so it will not easily remove proton from HSO4 minus ion. Okay. Okay, so second, in lecture number, I think second in third week. Okay, it is also explained how you can classify acids and bases according to Bronsted and Lowry concept. Okay, so all H plus donor, okay, all H plus donor, okay, will be considered as acid, where all H plus acceptor, okay, will be considered as base. Okay, so H plus donor means simply HCl. Okay, uh, okay, all acids are like, so I will not write H plus acceptor. Okay, so here I will write suppose NaOH. Okay, so what will happen if you add H plus ion here? Okay, in NaOH it will give Na ion plus water. Okay, but if you are adding H plus ion in ammonia, as I explained you just now, it will also give you ammonium ion. Okay, so here also accepting H plus ion and here also accepting H plus ion. Okay, but mechanism is different, but both are known as base. Okay, similarly, suppose ammonia, if you dissolve ammonia in water, okay, it will give you ammonium hydroxide, NH4. Okay, but ammonium hydroxide will be also found in ionic form. Okay, so ammonium hydroxide. So here you will can now according to Bronsted and Lowry theory, we can define them as a acid or base. So here you can say from ammonia to ammonium. Okay, so what is happening? It is accepting. Okay, it is a accepting of H plus ion. Okay, so it will be considered as base, obviously, because it is accepting, so it is base. We can say base 1. Then here water to hydroxide. Okay, so what is happening here? It is giving H plus ion. Okay, so we can say donating. Okay, donating of H plus. So it will consider as, because it is donating, so it will consider as acid. Okay, so this is the base 1, and after accepting ammonium ion, it will consider as, it will convert in base, sorry, acid, because now it can give a ion na, so it will consider acid. Okay, so it is acid first, because it is made from base 1, so we will write as acid first. But and also we can say it is a conjugated acid of ammonia. Okay, so it is a conjugated acid of ammonia. Similarly, the water, after losing of hydrogen ion, it will convert in hydroxide, and it is base. Okay, so it is a base, but this base is, so we can write here acid 2, so it is a base 2. but it is a conjugated base. Okay, this is all about the Bronsted-Lowry theory. Okay, so many examples are explained by sir, but I think this one example is sufficient to understand how we can define acid and base according to Bronsted and Lowry theory. Okay, is it clear? Any doubt in Bronsted and Lowry theory? Okay. So okay, in continuing our discussion, now we will discuss about amphiprotic species. Okay, amphiprotic. Okay, so according to its name, amphiprotic. Okay, so means it can give proton as well as it can accept the proton. Okay, so this type of species will known as amphiprotic, and simplest example is water. Okay, because it will give H plus OH minus ion. Okay, so it can accept, so here it is giving H plus ion, but this H plus ion can be again taken by another water molecule, and it will be converted as hydronium ion. Okay, so by this way we can say water can give hydrogen ion. Similarly, it can accept, similarly this water molecule accepting hydrogen ion. Okay, so it is giving hydrogen ion as well as it is accepting also hydrogen ion or proton. So this will known as a amphiprotic species. Okay, we will explain one more example. Okay, so this is suppose H2PO4 minus plus H3O4, similarly H2PO4 minus OH minus ion. Okay, so in first reaction what will happen, because it can give H3PO4, okay, plus water, and here it will take proton from this. Okay, so it will give you HPO4 minus 2. Okay, because one proton will be again move to hydroxide and it will make water. Okay, according to Bronsted and Lowry theory, you can define them. Okay, so which one is acid and which one is base? So obviously from hydronium ion to water. Okay, so it is giving proton, so it will consider as acid. Okay, and here it is accepting proton, so it will consider as base. Okay, suppose you are writing this is the base one. Okay, so it will be acid. Sorry student for wait. Actually Zoom has added one more features that after finishing one meeting you have to wait for 10 minutes. Then only you can start another meeting. That's why I have to wait for 10 minutes. Okay. Okay, so we were discussing about amphiteric amphiprotic species. Okay. Amphiprotic species. So as we wrote one equation, OH minus will give S3PO4 plus water, and here it will give HPO4 minus 2 plus water. Okay, so here water is what is, sorry, it is a 3. Okay, so water is giving proton, okay, from hydronium ion to water, so it is giving proton here, and here it is taking proton, hydroxide to converting in water. Okay, similarly this H2PO4 minus taking hydrogen here or taking proton here, and here it is losing proton. So these both species are we can say these both species are amphiprotic because it can give proton as well as it can take proton also. Okay, so on the basis of that we can explain this thing. Then a tendency of solvent to accept or donate proton. Okay, so similarly tendency of proton. Okay, so what is the tendency of solvent? Okay, so giving, suppose it is a acetic acid as, okay, and tendency of acetic acid to give proton is depend on solvent. Okay, which solvent you are using? Suppose you are using water, or suppose you are using HCl. Okay, so these are the two different solvent, water and HCl. In water, acetic acid will be dissociate lightly. Okay, then it will give H plus ion and CH3COM minus ion. Okay, where it will react with water, and you can say it is hydronium ion. Okay, but in HCl, because it is already acidic. Okay, so what will happen? HCl is more acidic compared to acetic acid, so it will give proton to acetic acid. Okay, and the acetic acid will be converted positive ion. Okay, and HCl minus ion. So what is happening here? Here acetic acid accepting proton, where, sorry, it is donating proton here. Okay, here it is donating proton D, but here it is accepting proton. Okay, so obviously it is known as, here it is behaving as acid, but here it is behaving as base. Okay, so according to this thing we can say that, okay, the nature of any acid, the nature of any we can say acid or any base, okay, it is depend on its solvent. Okay, if solvent is different, then its characteristic also change. Okay, then suppose one more we discuss about one chemical reaction, and here we will discuss about the oxidation number. What is the oxidation number? Okay, suppose it is S4 and it is reacting with I minus, okay, in acidic medium. So it will give you S3 AS4 O3 plus I3 minus plus water. Okay, so here in this reaction, uh, oxidation state of arsenic is being changed. Okay, so first of all, what is the oxidation state? Okay, suppose any suppose M is any metal. Okay, for any metal I am writing just M. If it is losing electron, I can say minus E. Okay, if it is losing electrons or one or more electron, so it will, suppose it is losing only one electron, so it will convert in M plus. Okay, because it has it has shortage of one electron. Again it is losing one more electron, so you can say now it is M plus 2, and likewise M plus 3, M plus 4, like that. Okay, suppose it is gaining one electron plus one electron, so it will convert in M minus 1. Okay, again it is gaining one more electron, so it will convert in M minus 2, like that. Okay, so this is known as their oxidation state. Okay, so according to which shortage or excess of electron, we can say which oxidation state of particular ion is this there. Okay, so here so in this chemical reaction we can explain how it is being happen. So it is arsenic. Okay, so how you will calculate the oxidation state sorry how you will calculate oxidation state of arsenic. Okay, so hydrogen here you I don't know that whether you know or not, whether you know it or not, but I will just explain. Okay, so hydrogen is generally providing generally found in H plus ion, where oxygen is found in minus 2. So oxygen state of oxygen is minus 2, where hydrogen is plus 1. Okay, so for this compound we can find out oxidation state. Okay, so it is plus 1, so there are total 3 hydrogen ion, so 3 into 1, then I can say X. Arsenic I don't know which oxidation state is it, so I am writing X here. Then oxygen I know that it is minus 2 form, so it will be, because 4 oxygen atoms are there, so 4 into minus 2. Okay, and the overall charge is equal to 0, because this molecule is neutral, overall it is neutral, so I am writing 0 here. Then I will calculate, so 3 into 1 3 plus X, 4 into minus 8. Okay, then X minus 5 is equal to 0. Okay, or finally I can say X is equal to 5. So oxidation state of arsenic is plus 5 here. Similarly you can calculate here, it is your homework, you can just do it. Okay, so it is plus 5 and it is plus 3. So when oxidation state decrease, means when it is converting in less positive, means plus 5 to plus 3, it is known as reduction. Okay, this reaction is known as reduction reaction. Okay, so I think this first point is clear. Now where this reaction is happening here, then yeah, now we will discuss where oxidation is going on. Okay, so here it is I minus. Okay, so you can say the oxidation state of I is minus 1 here. Okay, but here if you see, there are 3 iodine contain only 1 negative charge. Okay, so per iodine it is only you can say 1 minus 3. Okay, so obviously negative charge is decreasing here. Okay, or we are moving toward positive sign. So whenever we are moving toward positive sign, it is known as oxidation reaction. Okay, so this is the redox reaction where reduction is going on here and oxidation is going on here. Okay, so this is example of chemical reaction where oxidation and reduction is going on. Okay. Then suppose we will discuss about one reaction P just a minute. Ammonia, nitrogen plus hydrogen. Okay, it will give. Okay, suppose you are taking hydrogen here and nitrogen here, so 2NH3. So how much here? 3 is 6, so 3 hydrogen. Okay, suppose you are suppose this reaction is going on. Okay, and it is exothermic reaction. Suppose you are getting heat. Okay, suppose you are getting heat by this reaction. Okay, so what will happen? So here we will discuss about Le-Chatelier principle. Okay, okay, so here we will discuss Le-Chatelier principle. First of all, I will discuss about the temperature. Okay, so in this reaction, okay, if this reaction will move toward forward side or toward right hand side, it will increase temperature. Okay, so when I will increase temperature, okay, what reaction will do? Reaction will try to cancel this effect. Okay, so how this effect can be cancelled? If this reaction will move toward opposite side. Okay, because if this reaction will progress in right hand side or forward side, it will increase temperature. But I have already increased the temperature of the reaction procedure or reaction setup, so the backward reaction will be proceed. Okay, so the concentration of ammonia will be decreased, but concentration of nitrogen and hydrogen will be increased. Okay, so finally I can say that equilibrium shift toward left hand side. Okay, by increasing temperature, equilibrium shifted toward left hand side. Okay, clear? Then second example is, okay, suppose I am decreasing the temperature. Okay, I am here, what we are doing is we are decreasing the temperature. Okay, so if we are decreasing temperature means this extra heat will be taken out. Okay, so more product will be formed and reaction will move toward forward side. Okay, so this heat which is being generated while reaction, you are removing this heat. Or okay, so when you remove this heat, okay, by decreasing the temperature, the reaction will again, the equilibrium will shift toward right hand side. Okay, so this is the effect of temperature according to Le-Chatelier principle. Okay, similarly, similarly I am talking about the pressure. Okay, so second example is pressure. Okay, so what happen if I am increasing the pressure? Okay, what will happen if I am increasing the pressure? Because if you will count, one nitrogen molecule will react with 3 hydrogen molecules. So total 4 reactant molecules are reacting and converting in 2 product. Okay, so means 4 to 2 means when reaction will move toward forward side, the molecule of gases are decreasing. Okay, so means pressure is decreasing. Okay, means pressure is decreasing. Now we can understand what will be the effect of pressure here. Okay, so when you increase the pressure, okay, when will you increase the pressure? So the system will try to reduce the effect, or system will try to cancel out this effect. So how it will be do? Okay, so it will try to reduce the pressure. Okay, so how the pressure can be reduced? When reaction will move toward forward side. Okay, when reaction will move toward forward side, because 4 molecules are converting in 2 molecules of ammonia, so the pressure will be reduced. Okay, so by increasing of pressure, the reaction will move toward forward side. Same thing if you are decreasing the pressure. Okay, so if you are decreasing the pressure here, then what will happen? Because you are decreasing the pressure. Okay, so how it will be cancelled out? When, so the reaction will move toward backward side. Okay, so as you are decreasing the pressure, so system will try to increase the pressure. So how pressure can be increased? By reacting backward side. Okay, so equilibrium shift again in left hand side by pressure. Okay, so similarly you can correlate by concentration also. Okay, here also you can correlate this thing by concentration. Okay, so concentration what? Okay, concentration of reactant or product. Okay, if you are increasing concentration of reactant, okay, if you are rising or adding concentration of reactant, then obviously reaction will move toward forward side. But if you are adding the concentration of product, then reaction move toward opposite side. Okay, so this is the effect of concentration, and by this concept we can understand how our equilibrium will be disturbed by adding extra temperature, extra pressure, extra concentration, or by vice versa if we are going to reduce temperature, pressure or concentration. Okay, so this thing can be understood by this. Okay. Okay, now we will discuss about the dissociation constant of acid and base. Okay, so it is also very simple. Okay, suppose I am writing very simple acid H plus A. Sorry, suppose I am writing HA. This is a one acid. Okay, when it will dissociate, it will give you H plus ion plus A minus ion. Okay, so first of all I am writing rate of forward reaction. Okay, so what will be the rate of forward reaction? So it will be so the rate of forward reaction will be proportional to concentration of acid which we are taking. Okay, or this proportional sign can be removed by some constant. So we are writing here Kf means Kf forward reaction, then Ha. Okay, similarly what will the rate of backward reaction? The rate of backward reaction, it is also proportional to concentration of H plus ion and concentration of A minus ion. Okay, here also we can remove this proportional sign by putting constant, but here it will be Kb. Okay, then H plus ion and A minus ion. Okay, at equilibrium. Okay, we are discussing at the equilibrium. Okay, at equilibrium what will happen? Means forward reaction, rate of forward reaction will be equal to rate of backward reaction. Okay, so I can write like that, rate of forward reaction will be equal to rate of backward reaction. Okay, so I can say Kf Ha will be equal to Kb HNA. Okay, or I can write Kf upon Kb equal to H plus A minus divided by H. Okay, this Kf divided by Kb can be considered as you can say one constant here because it is acid, so we can write as a Ka. Okay, So this is the dissociation constant of the acid. Okay. So by this way we can calculate, we can derive how to find out the formula of dissociation constant of acid. Okay. So fraction of, so here HA is dissociating H plus and ion. So it is depend on acid. Okay. Suppose it is CH3COOH. Okay. So dissociation fraction will be different. Where if it is HCl, then dissociation fraction will be different. Okay. So according to that, if you are plotting the graph, okay, so you can say fraction of dissociation. So H plus will be like that. Okay. It will be at the lower, and here it is concentration of acid. Okay. So this graph is for HCl. Means at very dilute concentration it will be dissociate fully. Means factor is 1 means it will dissociate fully. But similarly, if you are drawing this graph for acetic acid, CH3, COH, then it will be like that, 0.25 factor on. Okay. Means only 0.25% of whole acid is going to dissociate. Okay. So for understand, I just explain this thing here. Okay. So according to dissociation constant K and Kb, okay, some other new terms are explained. Okay, which are Kw. Kw is ion product of H2O. Okay, means concentration of H plus and OH minus. It is known as Kw. Okay. Then Ksp. Okay. What is the Ksp? Sp means solubility product. Okay. So it will be, means suppose you are going to dissolve this ion in water, it will give you Ba plus 2 plus Cl minus ion. Okay. So this will known as the multiplication of barium concentration and chloride concentration will be known as their ionic product. Okay. So here we can understand that whenever the concentration of Ba and the product of Ba plus 2 and chloride minus is higher than Ksp, then it will be precipitate. Okay. Then it will make precipitate. Okay. So the value should be higher than their ionic product. Okay. Then formation constant, which is known as beta n. Okay. So here we can explain by this ion Na plus 2. Okay. When it reacts with Cn minus ion, then what will happen first? It will give you Na plus it will give you Ni plus Cn, or we can say just NiCn. Overall it is plus charge. Okay, one charge. So this charge we need to remove from here. Okay, NiCn. Then you can say, or we can say it is a B1. Okay, then NiCn plus again react with Cn minus. Okay, and it will give you NiCn. It will be neutral, beta 2. Then NiCn, because it is making complexing complex. Okay, so it will be surrounded by more ion, then it will give you Ni. So it will be 2 NiCn 3 ion, then one minus charge will be there, it will be week-3, and finally NiCn 3 minus plus Cn minus, it will give you finally NiCn4 minus 2. Okay, so this complex will give. Okay, so according to that you can find out the formation constant. Okay. Then again distribution constant, okay, KD, it is known as distribution constant, okay. Then it will be like, suppose by iodine we can understand, suppose iodine in aqueous, okay, iodine is dissolved in water, okay, and iodine dissolved in organic soil, okay. How it can happen? Suppose you have one beaker, okay, here it is water, okay, and at the top suppose you have, this is the oil, okay. So if you are going to analyze, some iodine is there and some iodine is there, okay. So you are going to analyze that how much iodine is there in what oil and how much iodine in water. So by this you can explain in this way, iodine, some iodine will be in aqueous and some iodine in organic, but organic iodine can come in aqueous, and similarly aqueous iodine can go in organic solvent, okay. So this type of equilibrium is established here. So it is defined by distribution constant KD, okay. So finally I will discuss about the salt hydrolysis, okay. Salts hydrolysis, okay. So what is the meaning of salt hydrolysis? Means if any salt is there, okay, A plus B, so one of the ion will be react with water, okay, and it will make means okay, it will make suppose okay, it will make salt and it will convert your system either acidic or basic, okay. How it will be happen? I will give you one example. Suppose it is NaOAC, okay. NaO means it is or we can write very beautiful form. Suppose it is acetic acid, okay. So I will write whole formula so you will understand better. CH3 COO ONA, okay. This is the salt of acetic acid and sodium hydroxide, you can say, okay. So when it will react when it dissolve in water, suppose, okay. So what will happen? It will give you CH3 COOH, okay. But the another ion, which is sodium ion will be here, but it will be surrounded by water molecule, okay. It will be surrounded by water molecule, and so not only sodium, it will be Na plus now, okay. So it will be attracted by water molecule. So what is the structure of water molecule? I think you know, but let me know. Suppose you can say like that, okay, because it is sorry like that, okay. So I can make, suppose it is oxygen, so here it will be hydrogen and hydrogen, okay. It is partially negative and these are partially positive, H2O, but it will not attract, no. Sorry, it's my bad, just a minute. You can write like that, okay. Delta plus and delta minus. So this partially negative oxygen will be attracted by sodium and it will form like, okay. Similarly, delta plus delta minus. Okay, so like that it will be surrounded by water molecule, so it will be not available. Okay, now so what will happen, from water H plus and OH minus will come. So H plus is already reacted with this salt and make acetic acid. Okay, and it will give you OH minus ion. Okay, so we can say this is the hydrolysis of salt hydrolysis. Okay, so by this way you can understand what is the salt hydrolysis. Okay, then one more thing, to understand and to derive the salt hydrolysis constant. Okay, we can understand one more example. So it is H plus H plus plus it is acetate ion only. Okay, when it will react, it will give HO2AC. Okay, or we can write water, when it will react, water will give you H plus plus OH ion. If you add these two equations, you will get H plus ACO2 minus plus water. Then here also HO2AC plus H plus OH minus. Okay, so here H plus and H plus will be cancelled. Okay, so only now you can say that this will be equal to 1 upon Ka, because it is just opposite of acid dissociation, so we can write 1 upon K. Okay, because it is just inverse reaction of the acid dissociation. Okay, so I am writing 1 upon K, and this is the only Kw dissociation of water. Okay, so to find out this total thing, KH hydrolysis of this acetate acetate salt, we can say, because it is minus, so obviously it will have some ion, and it is acetate salt, so it will form 1 upon Ka into Kw. Okay, so by this way we can derive the formula of KH. Okay. Similarly, by this way you can also find out the concentration. Okay, the pH value, pH value of any solution if concentration is given. Okay, so the formula for the to find out, first suppose you are going to find out OH minus concentration, so its formula is KH. KH you can derive from here, you can find from here, and if concentration is given of any salt, if concentration is given, then you can find out the hydroxide. Then from the concentration of hydroxide you can find out the pH. Okay, so how you can find out the pH? pH is nothing but minus logarithm of H plus ion. Okay, so like that you can find out, from OH minus ion you can find out H plus ion. Okay, concentration, and by this way you can find out the pH of the solution. Okay, so this is all about this lecture. Okay, one more thing is remain. Finally I will discuss this thing, which is common ion effect. Okay, okay, so common ion effect we have already discussed when we are discussing about the precipitation of ferric ion. Okay, where we are adding ammonium chloride and ammonium hydroxide. Okay, so here when so these both these two, one is salt and another is a base, will give you one same ion, which is ammonia. Okay, so what will happen, if you are, you can explain very nicely. Ammonium chloride will give you, it is also reversible reaction, ammonium plus chloride ion, whereas ammonium hydroxide will give ammonium plus OH minus. Okay, so what will happen initially? Suppose initially only ammonium hydroxide is there and this is not there. Okay, so ammonium hydroxide will be dissociated in ammonium and hydroxide ion. Okay, but when you add ammonium chloride, so this ammonium ion also will be there. Okay, so according to Ley-Satale principle, the concentration of ammonium ion is increasing or concentration of product is increasing. So when concentration of product will be increased, so equilibrium will be shifted toward left hand side, okay, or backward side. So the equilibrium will shifted toward backward side, so concentration of OH will be also decreased. Okay, and this concentration of OH is sufficient to precipitate ferric ion. Okay, that's why we are adding ammonium chloride in process of ammonium hydroxide. Okay, similar type of things are added in qualitative analysis of group element. Okay, so in second group we are using H2S in presence of HCl. Okay, again the same concept is here. Okay, it will give H plus ion plus 2H plus ion plus S minus 2 ion, whereas HCl give you H plus ion plus Cl minus ion. Okay, so as hydrogen is there, proton is there from hydrochloric and which is very strong acid. Okay, so it will okay, we can write like that. So this proton will shift this equilibrium toward H2S. Okay, and the concentration of sulfide will remain also decrease. Okay, and this sulfide concentration is sufficient to precipitate elements of group 2, which are copper plus 2, lead plus 2, okay, then Ag plus 2, bismuth plus 2. Okay, so by this way we can precipitate the sulfide of this ion, okay, like CuS, sulfide of this ion, okay, by using of common ion effect. Okay, so it is very useful for our analytical chemistry. Okay, so that's why we are discussing the main concept which are related to understand the concept of analytical chemistry. And when you are going to use different type of method, okay, then this type of concepts are very important. Otherwise you will not able to understand the mechanism of analysis, okay, which is very important to measure correct and accurate reading, accurate concentration, and in qualitative analysis accurate identification of particular element or particular compound. Okay, so this is the overall summary of week 3. Okay, I think it is clear. So now I will discuss about the assignment third of previous semester course. Okay, so it will help you to solve the assignment of this semester, this week 3, okay, ongoing semester. Just a minute. Okay, so we have already discussed all the concepts of week 3. So I think this question seems very easy to you. Okay, and also it will make very easy to understand. Okay, how you can answer this type of question. Okay, so yeah, first question is identify the correct statement from the following. Okay, so first statement is stalactites are recrystallization of CaCO3 from the ceiling formation. Stalagmites are recrystallization of MgCO3 from the ceiling formation. Stalagmite are the redeposition of calcium carbonate on the floor. Sorry. And last is stalactites are redeposition of MgCO3 on the floor. Okay, just a minute. Okay, so we already know that it is not MgCO3. Okay, so these two options are incorrect. Okay, so correct option will be stalactites are recrystallization of CaCO3 from ceiling formation. Okay, and stalagmites are redeposition of CaCO3 on the floor. Okay, so these two options are correct. Okay, so according to that we can say A and C is correct. Okay, so option B is correct. Okay, so this is the explanation. Stalactites are recrystallization of CaCO3 from the ceiling formation. Okay, when it will be dropped like that. Okay, but some CO2 will be swept out here from here, and it will make structure like that. So it is known as stalactites. Okay, and similarly, when it will drop on the floor, it will make this type of structure. Okay, so stalagmites are the redeposition of CaCO3 on the floor, and they form column. Okay, so it will be, if you see, it will be like continuous column. Okay, it will be only little gap in between them, otherwise it is a columnar structure. Okay, these are naturally occurring two processes are seen in Mammoth Cave. Okay, in Mammoth Cave or in India also, you can say like Burra Cave in south. Okay, in Visakhapatnam you can find out this type of structure. Okay, this reaction is already explained. Okay, calcium carbonate react with CO2 in presence of water. It is getting dissolved. Okay, it is getting dissolved means calcium is getting dissolved in water. Okay, so we know that calcium is able to dissolve in water. Okay, so this is only, but when CO2 will be swept out, okay, again this calcium will be converted in calcium carbonate, and it will form this type of structure. Okay, so these all things are written here. Calcium carbonate dissolved in water and saturated solution prepares CO2 sweep away and redeposit of limestone. Okay, what is the limestone? Limestone is calcium carbonate. Okay, so it is again converted in calcium carbonate. Okay, this is the first question. Then identify the correct statement of electrolyte from the following. What is that? So solute from the ion when dissolved in solvent. Okay, solute form ions when it dissolved in solvent. Yes, it is correct. Okay, then weak electrolyte ionize completely in solution. No, it is not correct. We already discussed a weak electrolyte like CH3CONA. Okay, it will not dissociate fully. Okay, so this statement is wrong. Then third statement is strong electrolytes ionize completely in solution. Okay, yes, strong electrolyte is completely ionized. Yeah, it is correct. Sorry. And last is electrolytes conduct electricity. So yes, electrolyte can conduct electricity. Why it is so? Suppose it is copper sulfate. Okay, so let me write. Suppose it is copper sulfate, it will give you Cu plus ion and SO4 ion, SO4 minus 2 ion. Okay, and suppose you are taking one cell. Okay, how it will look like? Suppose you are taking one cell. Okay, and you are putting two electrode. Okay, here you can provide one battery. This is the plus and this is the minus symbol. Okay, and it is filled with, suppose it is filled with copper sulfate ion. So it will be copper sulfate in water. Okay, so it will form, sorry, minus 2. Okay, copper plus 2 and sulfate ion. So what will happen when you switch on the battery? Okay, so negative will be act as a cathode. Okay, C for cathode, and it will be act as a anode. Okay, so because it is a negative terminal, cathode is negative terminal, so negative ion will be attracted toward cathode. Okay, so I can say that copper will be reach here. Okay, and sulfate is negative, so sulfate will reach at the positive. Okay, it is minus 2, so it will reach toward positive ion. Okay, finally copper will be deposited on the this electrode. Okay, and sulfate will come here and it will convert in another compound. Okay, so what is happening here means due to charge, these ions are able to conduct electricity. Okay, so means we can say that the flow of electricity is able to, okay, I is able to flow, current, I means current. Okay, current is able to flow in this circuit, means this solution is conductive. Okay, it is a electricity conductive. Okay, and why it is so? Due to presence of this ion. Okay, so yes, this is third statement is also clear, also right. So we can say A, C and D is right answer. Okay, so D1 is right answer because A, C and D. Okay, so I think this is clear. Okay, so I will just read it out fast. Electrolyte consist of solvent. Okay, dissociate positive and negative ion, or pure salt. Okay, it can be found in three things. Okay, positive or negative ion, or in pure salt. Solute from ion when dissolved in solvent. Okay, strong electrolyte ionize completely in solution, where weak electrode ionize partially. Electrolytes conduct electricity due to presence of ion. Okay, and the property of the electrolytes depend on the number of parameters such as size of the ion and the concentration, conductivity, interaction between electrolytes, electrode materials, etc. Okay, these are the parameters where the conductivity can depend, but we are not going much about that. Okay, but it is for your only basic knowledge. Okay, question number 3. Okay, so what is pKa value for acetic acid solution? Okay, so Ka value is given, and you need to find pKa value. Okay, so how you will find out pKa value? It is simple. Okay, pKa is simply like pH value. It is minus logarithm of K value. Okay, so if you can do by scientific calculator, just put this value 0.0000158. Okay, so so you will get pk value. Okay, so it will be around 4.75. Okay, you can do it by scientific calculator and you will get pk value. Okay, from here also you can find out the concentration. Okay, what will the concentration of hydrogen ion. Okay, so here the pk value means the concentration will be, just a minute, 10 raised to power minus 47. Okay, so like that you can find out. Okay, you need to study little bit about the logarithm, how logarithm is taken out. Okay, so you can understand this point very clearly. Okay, so okay, so pK was introduced an index for express acidity of weak acid, where pK is defined as follow. For example, K constant for acidic acid is this one. It will be equal to this one. Okay, 10 power minus 475. But the pK constant is 475, which is similar equation. In addition, the smaller pK value, the stronger the acid. Okay, so in addition, the smaller the pK. Okay, if pK value will be smaller, the acid will be stronger. Okay, the pK value of acetic acid is 4.75. Okay. Okay, so it is so you can understand by here it is 10 power minus 475. Okay, suppose any acid has concentration 10 power minus 2. Okay, so this concentration is higher compared to this one. Obviously it is minus 2. Okay, but if you will find pK value, okay, so if you will find pK value, then what will the pK value? It will be minus logarithm of 10 power minus 2. So it will be simply 2. Okay, so this pK value, here also I can write pK value. So pK value will be 2 here. Okay, so by this value you can say it is 2 and it is 4.75. Okay, but according to concentration you can say this concentration is higher, okay, compared to this concentration. Okay, so obviously the value, the pK value, the acid which has pK value 2 is more stronger compared to acid which pK value 4.75. Okay, I think this question is clear. Okay, then question number 4. Question number 4 is, which reagent is used for qualitative analysis of sulfate ion? Okay, so sir has explained about this thing. Okay, so sulfate ion, SO4 minus 2. So if this sulfate ion is present in solution, okay, to qualitatively analysis, or you sometimes we can also analyze quantitatively. Okay, so how we can analyze? We need to make precipitate. Okay, so how we can make precipitate? Okay, so we will add barium chloride. Okay, barium chloride will be dissociated in barium plus chloride ion. Okay, this barium ion will react with the sulfate ion which is already present in solution, and it will make barium sulfate. Okay, this barium sulfate will be precipitate. Okay, white PPT, we will get white PPT of barium sulfate, and this white PPT can confirm that barium sulfate is present. Okay, you can weight this barium sulfate. Okay, and can also calculate how much sulfate is present. Okay, and it can be also calculated by some instruments. Okay, like UV spectroscopy and like that. So it can be done in this way. Okay, so this same thing is written here. Add barium chloride to dilute sulfuric acid solution. Why sulfuric acid solution? Because it contains hydrogen. It contain hydrogen ion plus sulfur ion. Okay, so in dilute sulfuric acid we are adding barium chloride. It will give a white precipitate. White precipitate means barium sulfate. Okay. Separate the precipitate from the solution and add dilute acid such as HCl to the precipitate. Precipitate does not dissolve in dilute acid, so barium chloride is used for the quantity of sulfur. Okay, don't confuse with this thing. Only it is sufficient. When you add barium chloride, it will give barium sulfate, and it is sufficient for qualitative and quantitative analysis for sulfur. Then question number 5. Question number 5 is choose the correct statement for acid and base concept. Okay. So first is an acid is a proton donor. Yes, it is right. And if an acid is strong, its conjugated base is also strong. No, it is not correct. Okay. If acid is strong, its conjugated base will be weak. Okay. So first point is incorrect. Second, an acid accept proton to form conjugated base. Okay, good. And capable to give a proton. An acid accept proton. No, acid not accept proton. It is giving. It will give proton. Okay. Then third is an acid gives a proton. Sorry. Third is an acid give a proton. Yes, acid will give proton, right? To form conjugated base capable to accept proton. Yes. So conjugated base will able to again accept the proton. Okay. Suppose like that. HCl. So it will give H plus Cl minus. So this is acid. Okay. And it is conjugated base. So this conjugated base is able to again take proton. Okay. So according to this statement, this is correct statement. And final is sorry. Final is water is amphiteric solvent, but methanol is not amphiteric. Methanol is not amphiteric solvent. So it is not correct because methanol is also can accept proton. How it can accept proton? Because we know that oxygen has two lone pair and H plus ion can attract by this lone pair and it can make CH3 OH2 plus. Okay. So by accepting proton, this positive species can be formed. Okay. However, it can also CH3 COA. It can give proton. Okay, like that. CH3 so minus. It can give proton, so it can act as a acid, but it can take proton also. So it is also behave as a amphiprotic solvent. Okay, so that's why this statement is also wrong. Okay. Okay, so this is written here. An acid is proton donor, and if acid is strong, its conjugated base is weak. That's why our first point is wrong. A base accept proton to form conjugated acid capable to giving up proton. Okay. A base accept proton. Okay, base can accept proton to form a conjugated acid, and the conjugated acid is capable to giving up proton. Okay. An acid gives up proton to form conjugated base capable to accept proton. Okay, so it is conjugated base, so it can accept proton. Amphiprotic species are those which have both acidic and basic property. So water, methanol, ethanol are the such solvent which is used both acid and base. Okay, so I think this is clear. question number 6. What is the formation constant B4 of the following complex ion? Okay, what is the formation B4? So I have already written all this reaction. Okay, so in B4, this is the B4. Okay, and how you will write B4? So product concentration Ni CN4 minus 2. Okay, then reactant concentration, so it will be Na plus 2, then Cn minus, okay, so this will be the correct answer. Okay, so you can find out where is this, it is C. Okay, so C is correct answer of question number 6. Okay, so these all things are given here. Just a minute. Okay, so it is clear. Question number 7. It is depend on common ion effect. When AgNO3 is added to the following reaction, the equilibrium shifted in which direction? Okay, common ion effect as well as Les-Chatelier principle. Okay, you have to use two concepts here. Okay, common ion effect and Les-Chatelier principle. So when AgOAc will dissociate in Ag plus and OS. Okay, similarly when AgNO3 will be dissociate Ag plus okay. So similarly Ag plus NO3 minus okay. So now you are going to add this concentration, silver concentration means product concentration you are going to add here. So obviously equilibrium will shift toward left hand side or backward side. Okay, so more AgOAc, or you can say the salt will be precipitate more. Okay, and the concentration of OAc will be also decreased. Okay, why it is decreased? Because your equilibrium shifted toward left hand side. Okay, so now we can answer this question. The equilibrium shifted to the right to form more Ag? No. The equilibrium shift toward left to form AgOAc? Yes. The equilibrium constant? No. The equilibrium shift left to form less? No. Okay, so C is right answer. Okay, sorry, what happened? Okay, B is right answer now. So these things are written here, you can write only. Okay, the common ion effect refer to the decrease in solubility of ionic precipitate by the addition of the solution of the soluble compound with an ion in common ion with the precipitate. The behavior is consequence to Les-Chatelier principle for the equilibrium reaction of the ionic association and dissociation. The effect is commonly seen as the effect of the solubility of salt and other weak electrolyte. Adding an additional amount of the ion of the salt generally lead to increased precipitation of salt. Okay, means reaction will move toward backward side, which reduce the concentration of both ion. Okay, so ion concentration will be reduced and salt concentration will be increased. Okay, okay, so both ion and the salt until the solubility equilibrium is reached. The effect is based on the fact that both original salt and another added chemical have one ion in common. Which, okay, so which one is common ion here? Ag is common ion. Okay, so it is clear. Then find out amphitoric species from the following reaction. Okay, so it is also explained. Okay, here it is taking hydrogen ion. Okay, it is taking hydrogen ion here, and it is giving hydrogen ion here. Okay, so means it is taking also and giving also. It is taking proton and giving proton. So it is amphitoric. As well as water. Water is water can give here what hydrogen ion giving proton. Okay, so that's why, and converting in water, so water can give proton as well as it can take proton. Okay, so water is also amphitoric. Okay, so here B will be right answer. Both H2O and H2PO4 minus 2 can act as amphiprotic species. Okay, so D is right answer. Okay, amphitoric species are those which have both acidic and basic property. Water, methanol, ethanol are such solvent which are used both acid and base. Pyridine is basic in nature. Okay, so what is the pyridine? This is the pyridine. Okay, so nitrogen has lone pair, so it will act as a base. Pyridine is basic in nature and phenol is acidic nature. Phenol is what? Okay, it is also like that. So pyridine is basic in nature, phenol is acidic in nature. Okay, so it has a lone pair also, but it can give hydrogen ion also. Okay, so the correct answer is D, where both water and methanol is amphitoric in nature. When water acts as an acid, it gives H plus ion to the solution, and when it is a base, it will give OH ion to the solution. Similarly, H2PO4 minus 2 acts as a base in the first reaction, where it is taking hydrogen ion from water, hydrogen ion from hydronium ion. Okay, and in second reaction, it is giving hydrogen ion to hydroxide ion. Okay, so it is using reacting as a base. Question number 9. Identify the incorrect statement from the following constant. Okay, so we need to find out incorrect statement. A is equilibrium constant does not depend upon the rate of reaction. Yes, it is correct statement, because if your rate of reaction is fast, then your equilibrium will reach fast. Okay, but it is not depend on your rate of reaction. It will attain fast. Okay, equilibrium will be attained fast in less time of period if your rate of reaction is high, but it will not the concentration of product and reactant will not change. Okay, second is the the position of chemical equation shift in direction to relieve any stress of the system. Okay, any stress means either you are adding temperature, you are increasing pressure. Okay, so it will improve stress on the system. So what system will try to do? It will try to relieve this. Okay, and for relieve this stress, the equilibrium will move toward particular side. Okay, so this is also correct statement. Sorry. Statement C is with the change in temperature and pressure, equilibrium does not shift. This is the completely wrong statement. Okay, which we have already explained. As you will change temperature and pressure, system will try to reduce its effect, or it will try to cancel out the effect. Okay, then final position of equilibrium is depend on the root of equilibrium. No, you can select any root. Okay, it is not depend on that. So this is the okay. So C is okay. Means this is the correct statement. Okay. Okay. So you can say the final position of equilibrium is independent. Okay, not independent. So it is a correct statement. Okay. So only wrong statement is C1. Okay, so according to Les principle, describe the qualitative behavior of system where there is extremely induced instantaneous changes in one parameter of the system. It states that behavior shift occur in the system so is the opposite or partially cancel the parameter. Okay, the parameters are mainly temperature, pressure, mass action effect, density, etc. Equilibrium constant does not depend upon the rate of reaction. Okay, rate of reaction only it will be again fast. Equilibrium will be attained fast or late according to rate of reaction, but it will not depend on rate of reaction. Okay, final position of equilibrium is independent of the root of equilibrium state. Okay, so the statement C is incorrect. Okay, clear. Finally, the last question is, if the acid is strong and base is also strong, what will the nature of their salt? Okay, if acid is strong and base is also strong, so obviously the salt will be also strong. Okay, we can understand by one example. Suppose HCl and NOH, it will give you NaCl, so NaCl will be strong, so the strong is right answer. Okay, B is right answer. So if the acid is strong and the base is also strong, then the nature of their salt will be also strong. The salt will be very good electrolyte, that means it will be soluble in water properly. For example, HCl is strong acid and NaOH is strong base, so NaCl is strong salt. It is very simple question, I think. Okay, so this is all about this session. Okay, you please go through all the video and do your assignment, and you can write me if you have any doubt. Thank you.